Hello everyone. Today inshallah we will start our lecture and we will start the second part after our exam. We will talk about differentiability in either in R or in Rn, and also I will just push the line a little bit to go through vector valued functions inshallah. This topic is really very important. It contains plenty of applications, and also we will go through it exploring the differentiability in R or in functions with several variables, and as I told you, with vector valued functions. All the resources and everything you will find them on Moodle, and also the recorded lectures you will find them on YouTube. Okay, as I told you, our today agenda, we will continue the definitions of partial derivatives, the laws, then higher order partial derivatives, we will go through it, the gradient vector of f when we need gradient vector, and also the Hessian matrix of the function, and I've added a couple of examples from the previous exams and also from the sheet. So this is differential calculus, as I told you, and this is our lecture. What is the meaning of derivative, or what's the difference between total derivatives and the partial derivatives? Actually, this needs a good understanding about the type of functions that you are dealing with. If your functions from R into R, and from one variable into another variable, so we will use total derivative. Usually, derivative, it is the rate of a change of the output relative to the change in the input. The geometric interpretation, as you can see, if this is f of x, this line, okay, and if I want to get the difference between the value of the function and f of a, the value of f at a, this is the increment or the change in the output relative to the change in the input. This is the slope of the tangent, which is the rate of a change, which is the derivative. We usually symbolize it by f dash at a, so it is the ratio of a change of the output relative to the input with a little increment at point A. This is the f of x minus f of a divided by x minus a, dividing the increment in the output relative to the increment in the input, which will lead you, if this change is really minor, you will have your definition or the main law of derivative, which is limit h tends to 0, f of a plus h minus f of a divided by h. This is the law by definition. We will use it, Ya Omar, if you are requested to find the derivative of a function using the definition or using the first principle. Then I will have to use this law, which is limit, once more, limit. H stands for the increment, which is x minus a. So it is just only the change in this period. This is h. This is the part of h. H is x minus a. So it's the limit of h tends to 0 of the difference in the output divided by the difference of the input of your function. While h is really very small or a very small increment, this is what we mean by derivative. For example, if I want to evaluate f dash 1 with f of x, or for f of x equal len of x, using the definition, because as I told you previously, we can differentiate using the general methods, as you will see from the coming slides, but mainly in this step we will use the definition. So all I have to do is to apply this law near the point A. Since he need to find f dash at 1, which means f dash at a, so a is equal to 1. That's Muhammad f of 1 plus h minus f of 1 divided by h. And this is what I'm going to do. I will write the law. So now if I want to find the derivative for this function, it's using the first principle, بص يا عمر, and you will have to use your pen once more. All I have to do is to write f dash of 1. It is the limit of h tends to 0 for the value of the function at 1 plus h minus f at 1 divided by h. You have to use your pen. You have to rewrite this law in order to be familiar with. The second step, Mr. Muhammad, is really very easy. All I have to do is to do substitution. So I need to find f of x, which is then x. So f1 plus h, it's gonna be a limit of h tends to 0 for the function len of 1 plus h. So it's gonna be len 1 plus h minus the value at 1, which is len 1 in my case, or in this case, divided by h. Remark, if you try to solve this limit this way, of course, now I'm evaluating f dash at 1. If you make the substitution, you will have len 1 equal to 0, len 1 plus 0 is going to equal to 0, so the denominator is equal to 0, while the denominator is also 0, so it's a 0 by 0. So I will have to do some simplification or think of something in order to be able to evaluate this limit. There is plenty of ways to prove or to solve this problem, but I will use this expansion for the limit, for the len, I'm sorry. So it's a limit, len h tends to 0, len 1 is equal to 0, so I'm stuck now with len of 1 plus h divided over h. One of the very nice ideas, and we already have this previously in the foundation or in your previous studies, and we will go through it later inshallah, which is Maclaurin expansion. If I want to expand len 1 plus h using the Maclaurin expansion, the expansion, Mr. Muhammad, will be h, then minus h squared over 2, then h cubed over 3, minus h power 4 over 4, plus and so on. This is the expansion of len 1 plus h. So all I have to do is just to replace this guy by this value. So it's going to be a limit of an h tends to 0, and start substituting. If you remark, all these terms contains h, so I can take h as a common. Am I right? Take h as a common. If you take h as a common, you will have from the first term 1 minus h over 2, then h squared over 3, minus h cubed over 4, blah, 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 divided by h. Now I can eliminate, Mr. Omar, these two values of h together. And then, Mr. Hussein, I can take h tends to 0 and substitute. In this manner, all of these terms are going to be 0. So the limit is equal to 1. This is how to evaluate. Also, I want you to know, this is the general evaluation, but one of the famous laws of the limits is the limit of h tends to 0 of len 1 plus h over h, it's equal to 1. This is as a law or something, or one of the famous problems that I can use its value, okay? We will need it down the road. But I wanted to go through why in this example it's equal to 1. All I have to do, as I told you once more, is to just find an expansion of the denominator and try to just simplify by using the common factors and dividing on the value. Then you will find your problem is really in front of you and it's solved. Okay, once more I will resolve it. خلي بالك معايا عمر. Once more, boss. This is lim f dash at 1. So once more, it's a limit of len 1 plus h minus len 1 over h. The second step, I will try to substitute. It's going to be 0 over 0. So I will have to simplify it. How to simplify it? I will break len 1 plus h. I think Maclaurin expansion is really very nice. So instead of having len 1 plus h, I will use h minus h squared over 2, h cubed over 3 minus h power 4 over 4, and so on. If you take this expansion, you will remark all the terms contains h. Take h as a common. So it will be deleted with your denominator, and you will end up having this series. All I have to do is to substitute h equal to 0. So all of these terms are going to be cancelled, and the value is equal to 1. Let's do another problem and see if it is differentiable or not. So right now I'm using the total derivative law, which is the limit of a plus h minus f of a divided by h. Once more, any ideas how to solve this problem, Omar? Any ideas how to solve this problem? Okay, ما انت عشان تبص الموبايل. Okay, compute f dash 0. Okay, yeah, regardless. معجب بالإزازة؟ جميلة صح؟ اديني هنا بس. بيقول compute f dash 0 with f of x for the function x minus 2 root x squared. أول step, I want to do it using the definition. What's the definition? Do you remember? ها؟ عمر? Okay, it's gonna be f dash at 0, which is gonna be limit h tends to 0. For whom? For this function at h plus a. In my case, it's gonna be h plus 0. So instead of x, replace every x by h plus 0. Let's do it together. So it's gonna be h plus 0, then minus 2. The h plus 0, it is the value of x. Really very simple. Square root 4. Replace x. So it's gonna be h minus 0 to the power of 2. And all of it is divided on h. But don't forget minus the value of the function at 0. اتفضل just a second. f at 0. المين لو بيقول ايه المين لو؟ بيقول limit h tends to 0 f of a plus h minus f of a over h. مش ده اللو؟ طيب this value is h plus 0 because I'm evaluating at 0, so a is 0. Okay? طيب minus the value of the function at 0. The value of the function at 0 كام عمر؟ أنا آسف بكام يا حسين؟ It's gonna be 0 minus 2 times 0. So the value equal to 0. Now I want to solve this problem. Once you try to solve this problem, you will have the following. You will have, that's the limit of h tends to 0 of h minus 2, but you ended up having a square root of h to the power of 2, which is divided on h. The problem with the square root for h squared, that you will have a positive or negative values. Am I right? So, in this case, you will be between two values. If the limit h tends to tends to 0 and above from the right hand side, if it is from the right hand side, you will use the positive. So it's gonna be h minus 2 times h over h. Once you eliminate these two guys together, the value will be negative 2. If I did the same with the negative side, I will have the limit of h tends to O negative for h minus 2, but in this case I will have negative h divided by h. They will be cancelled both together and the result is equal to 2. My question, in the limit from the left equal to the limit of the right, you are approaching 0 from the left and from the right. It's supposed to be the same value, but it's not the same value. There is a difference, as you can see. So from this means, of course, once you eliminate and both h equal to 0, they are not equal to each other. So the limit doesn't exist. Once the limit doesn't exist, this means you don't have a derivative or for this function for x minus 2 within that square root of x squared at x or at this point. So f dash 0 doesn't exist. So once more, let's do it together, but please, I want you to remember my words. You will have to use your hand. Try to solve as much as possible from these problems. It will give you good understanding and it will be also easier for you. So once more, this is x minus 2 root of x squared. This is the law that we are going to use, f of a plus h minus f of a over h, as you can see. Here a is equal to 0, so all I have to do is to make a simple substitution. It's a direct relation. So simplify it a little bit. Now I have the root of h squared, Mr. Muhammad. So in case if you are with 0 positive, you will have negative 2. In case if you are approaching from the 0 but from the left side or from the other side, you will be using a negative h, and so the result will be equal to 2. These two results are not equal to each other, so the derivative at 0 doesn't exist. Okay, once more, I want you to remember the general derivative rules or the total derivative rules in general. Tell you once more, we use total derivative in case our function is from R into R. So you are mapping elements from R into R, okay? In this case, I will have the sign of the derivative dy by dx. Because as we know from the previous lectures, we have three types of function, if you remember. From R to R, it is the general functions or functions in one variable. From Rn into R, we have several functions and several variables, our multivariable functions. For functions from Rn into Rm, in this case, we have vector valued function. So how many types? Three types. The first of them with the general rules, okay? These are the general rules. It's the total derivative. And also will be followed in partial derivatives. Mr. Omar, the derivative of any constant, the value will be equal to 0. Derivative can be distributed on addition and subtraction. Derivative can be distributed, a constant can be taken outside derivative sign. If you have two functions multiplied in each other, what's the derivative law? I will differentiate the first times the second, plus differentiating the second times the first. معايا Mr. Muhammad? If I have two functions divided in each other, I will square the denominator, then find the derivative of the numerator times the denominator minus vice versa. That's the law of the derivative of two functions. Those laws also is really very important. If you have u to the power of n, the derivative will be n times u to the power of n minus 1. If I have exponential functions, e to the power of u, what's the derivative in this case? It will be the main function, e to the power of u, times the power, which is u dash. If I have len u, in this case the derivative will be 1 over u times u dash. Okay? If I have a to the power of u, it will be the same function, e to the power of u, times len el base, which is len a, times the derivative of the denominator, the derivative of the power, which is u dash. If I have log u for base a, it will be 1 over u times u dash times len a. Those are the main derivative laws. Of course, you will have a derivative formula sheet in your exam previously, like the formula sheet that we used in the previous exam. It will contain some of these rules, but also you will need to remember them. It will make your life much easier if you just memorize them. Okay, that's for the total derivative as I told you. Now we will go to differential calculus, but in this case in Rn. So Rn covers two things. The functions in several variables, which is the second type, and also it's an introduction for the functions for the vector valued functions, which is functions with more than one output. So in this case, the partial derivative in general, I will need partial derivatives. Okay, first let us revise. This is the main law of the derivative in one variable, which is f of x minus f of a of x minus a, the law that we have. In the case of having functions in several variables, the law will be a little bit twisted. This is gonna be the law. So, Mr. Hussein, a law in this case, or the derivative in this case, I will have to determine which variable, because you have more than one variable. So, once more, in the previous law, you were using, okay, dy by dx. And in this case, your function is running R to R. So it is just only linking one variable as an input with one variable as an output. And the limit is really very simple. It's a limit of an x tends to 0 or h tends to 0 of f of x plus h minus f of x over h. That's the main law. If you are differentiating or studying at a certain point, so this is going to be f of a, and that's also will be f of a. But once you go to variables or functions in more than one variable, the start will be with R2. So it's a function such that I'm running from R2 into R. This is the simplest type of functions representing Rn into R. So in this case, I will have how many variables as an input? 2 of them. And what's gonna be the result? Just only one output. So it's a function in several variables. Type, for functions in several variables, if I want to differentiate, I can. But you will have to determine at which dimension. So I will find the first derivative in the x direction, or find the first derivative in the y direction. This is why it's a partial derivative. The sign of the partial derivative, it is partial f divided by partial x. In this case, I have 2 values, a and b. If I'm using the definition, I'm in the direction of x, so the first coordinate only will feel the change. بص كده يا محمد. It's gonna be f of a plus h, and the b is constant, minus f of ab divided on h. This is in the direction of x. If you remark, I added the h, the increment, in the x direction. Like if I'm making a derivative in the y direction, ya Hussein, I will do exactly the same. A will be a constant, but the change in this time will be within the second component, is y. So it's gonna be b plus h, while this is b. If you remark, those are special cases from the window. I'm applying 2 times. If I'm in the x direction, I will use a plus h and b minus f of ab. If I'm in the y direction, I will use f of a, then b plus h minus f of ab divided by h. This is very, very simple. All I have to do is to follow the steps and you will be able to find your derivative. There are different notations for partial derivatives. Also, you should be familiar with all of this. If I wrote partial f, partial x of ab, I can also symbolize it by f sub x. F sub x. Or to use the dash stand for the number of the derivative, the first derivative, with respect to x. So any of these forms are exactly the same as you are using the first principle. How can we interpret the value of a partial derivative? This is the interpretation of what's happening. So partial f, partial x, which is the partial derivative in the x direction, represents the rate of the change of f at AB when having an infinitesimal change in in the x direction. Infinitesimal, it means very small. This is why we are taking h and we are making h tends to 0. This is why we are using the limit of h approaches 0, because the percentage of the increment or the increment is really very small. Okay? Same definition applies for y. And I've also sent this PDF to be with you all, so I think there will be no problem in reviewing the laws or the definitions. You really have them. I think I sent it to you within the weekend, through the weekend. Okay. Also, from the law of f of x minus f of a divided by x minus a equal f dash, I can get the value of f of x, which is y. So for any differentiable, if f is differentiable at certain point, there exists a tangent line to the graph of f at a and the f of a. This is the law of the tangent, which is y equal to the value of the function at x equal to a plus f dash a times x minus a. By the idea, this law can be generalized in the case of 2 dimension, because if you remark, this is the interpretation or the geometrical explanation in one variable from R into R. But if I am in Rn into R, I will have a hyper plane. Instead of having the tangent as a line, I will have a plane touching your shape if I'm in 2 dimension, and a hyperplane if the dimension is more than this. And this is the interpretation of the value of your tangent plane. Here he's asking you, compute if they exist, f dash x at 0 and 0, and the f dash y at 0 and 0. This is the partial derivatives, as you can see. Okay? Imagine, just imagine that you are reviewing or revising all of this هم دول.
بحس ان الحاجات دي اصعب بكتير قوي من بيدرس 1. بكتير قوي.
لا مش اصعب ولا حاجه.
والله اصعب يا
مش بكيفنا.
ايه؟
مش بكيفنا. يعني احنا نقدر نحل ده عادي بس هو مش بكيفنا. انت لازم تاخد الاول بالفيرست برنسبل، بعد كده تاخد اللوز بتاعت البارشل ديريفاتيفز، بعد كده هتاخد ليفل اعلى من كده ان الكورس بتاعك فيه اوتومايزيشن. فهو ده مش الديبيت اللي احنا بنتكلم فيه دلوقتي. معايا؟ هو مش بكيفنا يعني.
حاجه صعبه قوي.
ده مش صعبه، بس المهم انك انت تجرب انك تحاول انك تحل ده بايديك. ماشي؟ طيب ازاي تو جو ثرو؟ وبعدين نقطه كمان محمد، برضه طالما انت ذكرت ده احنا بنريكورد عشان الباقي يسمع. It's a huge difference between the level of difficulty in here in IMAS compared to SBE or FCT. It's not a joke. Okay? بس المين ايديا حاول تفهم او تخلي بالك احنا ليه بنعمل ده. المساله اللي موجوده قدامك ده موجوده دي انا ما اقدرش اوجد لها بارشل ديريفاتيف، لازم ادرسه من البدايه. هي العمليه مش تلطيش. اللي انت كنت واخده قبل كده خدت بعض علاقات بتاعه الديريفاتيف بس الجنرال ريليشنز زي الجدول اللي انا اديته لك الاول. الجدول اللي انا اديته لك الاول والناس ده اللي بتدرسه، ده اللي بتعرفه. لكن what's behind the scene انا بستفيد بيه في ايه؟ مش كل الناس عارفه. Okay. So once more compute if they exist f dash x او the first derivative with respect to x in the direction of 0 and the first derivative with respect to y around the origin or near the origin. طيب يعني ده معناه هستخدم اللوب. يا ترى تقدر تقول لي اللوب؟ فاكر اللوب؟ طب ده لسه بدور لك حاجه لحقت تنساه. اللوب بيقول ايه؟ تعالوا معايا كده. f dash at 0 and 0 بس انا في الدايركشن بتاع مين؟ صح؟ يبقى ده ليميت x و y صح؟ x و y دول هيروحوا لمين؟ لزيرو صح؟ لزيرو وزيرو. يبقى انا دلوقتي مش هي دي الليميت اللي انت عايز تحسبه؟ اوكي يبقى انا هجيب the value of the function f of 0 plus h والواي بيساوي 0 يبقى الانكريمنت اللي انا عملته في الاكس دايركشن. بالتاكيد هيبقى ماينس f of 0 and 0 divided by h. All you have to do is to make the substitution. Start substituting by these values. Once more عشان ما تحسش ان الامور يعني مكرره. Once more. h tends to 0. f of 0 plus h and 0 minus f double 0 over h. I will have to do the substitution. Okay, once we are here, so start to use the value of the function, which is, let's substitute together. Yeah, عوض معايا. Instead of x, 0 plus h, which means h to the power of 2, minus 0 divided by h plus 0. So it will be h squared over h. So this guy is h squared over h, which is h. Minus the value of the function at 0 and 0. The value of the function at 0 and 0, it will be 0. So the value is equal to 0 with no substitution. طيب بص كده it's an h squared over h, so it's gonna be h, which is gonna be eliminated with this guy. The value is equal to 1. So the first derivative with respect to x already exists, and the value is equal to positive 1. طيب أنا عايز أعمل partial derivative with respect to y. Same law. بس هيبقى الديفرنس فين مستر محمد؟ بدل ما ده 0 بلس اتش و0 لا في الدايركشن بتاع الواي second coordinate يبقى f of 0 and 0 plus h. Are you with me? So once more بص اللوب يبقى لما كنت في الاكس دايركشن كان 0 بلس اتش and 0. لما ابقى في الواي دايركشن الاكس هي اللي بزيرو، الواي هو اللي هيبقى 0 بلس مين؟ Let's do the substitution. هيدي لك 0 minus h squared على 0 plus h يبقى اذا على طول السكند ستيب negative h squared over h. So it's going to be negative h divided by h is going to be equal to negative 1. In this case, I have the partial derivatives in the x direction and in the y direction. In the x direction, the value of the derivative is going to equal to positive 1. In the y direction, the derivative will be negative 1. So, and that's how we get the first and second derivative. By the idea, I have here also compute, if it exists, f dash y at the origin with the function y plus 2 then x plus e. By the idea, I can differentiate using the general laws of the partial derivatives. You differentiating only with respect to the variable that you are differentiating with. The second variable is going to be a constant. What I mean? I can simply get f dash of an x and y with respect to x. So I'm making the first derivative, I'm sorry, but let's do it this way in order to see it as the solution. I'm going to do the derivative with respect to y. Let's differentiate together. This function contains this part and that part. Am I right?
Yes.
The first part contains y. Differentiate the y. So differentiating y is going to equal to 1. So it's going to be 1 times, because 2, the derivative with respect to y is going to equal to 0, times the second part, which is a constant. So it's going to be ln of an x plus e. Then plus 2 functions multiplied in each other. The first of them will be y plus 2 times, if this function contains y, this part, do you have y? Do you see y in here?
No.
So the derivative with respect to y will be
0.
because it's a constant. Here you are choosing the derivative, the variable that you are going to differentiate with respect to. So if I'm differentiating with respect to x, I'm going to change only x, considering y as a constant. If I'm differentiating with respect to y, I will differentiate with y, considering the rest of the problem as constant. And I will deal with it as constants, as numbers. So the derivative of this function is going to be ln of an x plus e. Imagine in your exam, if it is required to justify or to choose multiple choice. It's really very simple. The problem is when I tell you justify your answer, I'll use the main principle or the definition. Or you will have to do it in case of you are studying if the function is differentiable or not. So once more, if I want to get the derivative, after getting the derivative, of course, I will make a substitution. So once more, Muhammad, if I want to differentiate, so simply, it's going to be f dash of x and y with respect to x. With respect to y, so I'm differentiating this guy. This is the only part which is going to be 1 times ln of x plus e. But I want the first derivative with respect to the origin. So substitute. Instead of x and y, put 0 and 0. So f dash y at 0 and 0 will equal to ln 0 plus e, which is ln of an e, which is equal to positive 1. So I can bring these problems. Either you can solve and justify your answers, or just to use a multiple choice as a type of a question. Okay? So once more, if I want to solve it, this is y plus 2 ln x plus e. With respect to y, add the values of 0 and 0, it's going to be ln x plus e, replace x by 0, so the value is equal to 1, as you can see. In this case, I'm not using the definition, I'm using the general laws of the derivative. For this function, another problem. For this function, here he asked you to use what?
Definition.
What's the definition? The limit law. So if he didn't ask you about the definition, start using like the previous problem. But in case he wants you to use the definition, then I will use the limit. Okay, so once more, I will need to find the first derivative of f with respect to x at 1 and 2, and the first derivative of f with respect to y at 1 and 2. Can you remember the law? Limit h tends to 0 of f plus h and b minus f of ab divided by h. صح? Once more. This is f partial x at 1 and 2. I will change an increment in the x direction. So instead of dealing with 1, I'm talking about 1 plus h. And this is going to be f of 1 over 2. Just to make a general substitution. So in this problem, I will replace every x by 1 plus h. And the every y by 2. And in the second case, I will substitute instead of x and y by 1 and 2. So once more, this part, just a second. This part, it is the value of this function at 1 plus h, which is gonna be 1 plus h to the power of 2, and replacing y with 2. So it's a 2 to the power of 2 equal to 4, minus. I will substitute by 1 and 2. Let's substitute together. 1 to the power of 2, 1. 2 to the power of 2, 4. So 9 minus 1 minus 4, it's gonna be minus 4. Am I right?
Yeah.
9 minus 5. Okay, start to simplify your life. Okay, I will try to see what's gonna be added, what's gonna be subtracted, and so on. By expanding this guy, which is gonna be 1 plus 2h plus h squared. So this is the expansion, and then I will try to eliminate the numbers. You will have negative 4, which is negative 8, and then you will have negative 1, minus 1. So all of these numbers are erased together. I will take h as a common and eliminate it. So it can be h of h minus 2, as you can see, or plus, and this is not minus, negative sign. I will eliminate these two guys and then take the limit, so it's gonna come up to negative 2. Are you with me? So this is what's happening if you are getting the first derivative using, once more, using the definition. Okay? طيب, can I do it without the definition? Yes, of course. لو انا حبيت اعملها من غير definition، قول لي البروبلم كده بتاعتنا f 9 try to find f sub x, differentiate with respect to x. So it's gonna be negative. صح؟ ما هو 9 derivative بزيرو والy derivative بزيرو لانه it's a constant. طيب روح بقى من دي هات لي f of 1 and 2 عند x. بشيل x واحط 1، طلعت الفاليو بكام؟ اهي. طيب can you do it with respect to y? Can I do f of y? Yes, of course. F of y will equal to, differentiate with respect to y, so it's going to be negative over 2y. Once more, fy at 1 and 2, الكلام ده يساوي, it's going to equal to, replace y by 2, so the result will be, am I right? Okay, let's see if this is going to be the result using the definition. So using the definition in the direction of y, it will be exactly the same, but just only with minor change. This is going to be 1, but 2 plus h, this is going to be 2, and then I will use the expansion. Oh, once more, this is f of 1, 2 plus h, minus f1, 2 over h, as I told you. Then start making the substitution. It's going to be 9 minus 1 minus 2 plus h to the power of 2. If you try to simplify, exactly the same, expanding this guy, which is going to be positive 4,